Now, we all know Mia used to make the best videos.
Key word, used to. Riley makes the best.
Mia.
Riley.
Mia.
Riley.
Mia.
Riley.
Whoa, stop. We all know Ian's are working too hard because Kim West is the best. Now let me show you the right direction to go. Let's go this way. Are you still on your phone? Yeah, okay. Just like school too. Oh wait, that's right. You don't go to school either, so there's that. Do you know what even happened here?
Energy and work.
You had to look though. Okay. So whenever you and Draven were arguing who's the better video maker, aside from Kim West, but anyways, you guys were doing work, and the reason why is because whenever Draven pushed, it displaced a little bit, and you didn't know that. Work is displacement of an object, which it gives it kinetic energy as well. You know what that is, right? You gonna use Google or something to like look that up next too, or like what? Let's hear it. Yeah, come on.
Kinetic energy is the energy an object has because of its motion.
Yeah, there we go. Okay. You're not wrong. I still know you don't know what that means. So basically, whenever an object has motion and it goes in a certain way, so whenever Draven pushed it this way, or no, you were on this side. You pushed it this way, it had a little bit of kinetic energy and it was doing work since it moved a tiny bit. And whenever Draven pushed it back, his was negative, being that it was going in the opposite way. And then whenever I was on top of the table, that also gave. Are you listening?
Yeah.
Anyways, whenever I was on top of the table, it gave it potential energy. Well, I had potential energy because I could have popped down. So I would have fell since I had a height, I have a mass, and gravity's working on me, right? Okay. But there's also another type of energy that we didn't discuss. It's called potential elastic energy, right? You know what that is, right? Okay, so potential elastic energy is something that can be stretched or compressed. It has its own coefficient of depending on what type of material it is or just what its coefficient is. And basically it's just how much energy it stores in one go. So like, do you understand any more what's going on?
Yeah, that makes a lot of sense.
Really? Really, what did I just say?
Work.
Go to school for once in a while, maybe.
I got murder on my mind.
Man, it is hot outside. We got some study guys here. Never mind, Jalal's here. Oh, what do you do? Oh, never mind, you're not studying. You're on your phone as usual. Well, what are you doing? Oh, you're doing physics. Wait, is that fit? Get out of here again! You gotta be kidding me with all this. Really? Leave. Come on. Really? Take some water with you. Yeah, leave. Yeah, that's what I thought. Gone.
Oh, hey, I didn't see that.
Oh, hey, Drizzy. How you doing?
Pretty good.
What are you working on?
Some conservation of energy stuff.
Really?
You want me to tell you how it goes?
Sure, it sounds complicated.
But here, I'm gonna break it down, okay?
Okay.
So, in my big noggin, I wrote all this down for you guys.
Okay.
So, first type of energy you have kinetic energy, okay? Which is Ke equals 1/2 m times v squared. The m stands for mass, the v stands for velocity. You know what I mean?
Yeah.
Then we have potential energy, okay? We have PEG, the G stands for gravitational force, times mass, times gravitational force, times the height. Then the last one we have is elastic potential energy.
Okay.
This is PES, the S, and no one really cares about that. We have 1/2 times K times X squared, okay?
Okay.
Then the last one we have is work.
Work.
Which Jalil does none of, as you saw.
Yeah.
is W times the force times the distance times the cos of however someone's standing. So if we're standing still like this, it's 180.
So, like, if I'm standing flat.
Yes, basically, essentially.
Okay.
Okay. So let me show you an example of kinetic energy.
Okay.
So in this big brain of mine,
Your big brain.
I decided, let me calculate what the kinetic energy of that segment was before with me and Jalil. So I sat down and said, okay, let me do it. So I got the equation. And then I weighed the table. Don't ask how I weighed the table. So I came up with 50 kilograms, like on here, okay? Then I figured out how fast both of us were pushing the table.
Okay.
That was 2 meters per second, okay? So I wrote it down in the equation. So you take the 1/2 times the 50 kilograms times the 2 meters per second. Make sure you square it. I'm talking to you out there. So you multiply all that up, and you come up with 100 joules. Okay?
Okay.
Okay. So then...
Oh. We're not done?
No.
Man, these problems suck.
Yeah. So, then I said, since, kind of in this video we had to do work, I said, you know what, I'm going to calculate the work. So, I decided to sit down, do the same thing I did with the other problem. So, I weighed the table again.
I'm listening.
Doesn't seem like I was listening. I
I'm
weighed
sorry.
the table again. And it's 50 kilograms. Then, I tried to calculate how much force were we actually pushing with both of us. And I came up with 100 newtons. Okay?
Right.
Now, since we're pushing in opposite directions, I made mine negative and his positive. Since
Right.
I'm on the left. Okay?
Okay.
Then I came up with how far did we actually push? We actually only pushed it 0.01 meters.
That's a centimeter.
Exactly.
Man, you guys are weak.
I know.
Well, Jello is.
Yeah.
Okay.
Yeah. Anyways. So, I got the equation, and I said, okay, I'm going to calculate this. So, with work, you take force times the distance times cosine. Since we're standing still, it's 180. So, you do negative 100 times 0.01 times the cosine of 180. You come up with 1 joules. I did the same thing with Jalil, but in this time, his was negative because since we're in opposite directions, I made the cosine negative since we're pushing in opposite directions. And I came up with negative 1 joules. Then, to find the whole work in total, I did the work total, which is 1 minus 1, which is 0. So, in total, we did no work.
Oh my god. Wait, what's that stand for?
Joules.
I thought it meant 0 Jalils. Speaking of it. What are you doing? Honestly, you're not welcome here no more. Jesus. Alright, it was nice seeing you though. I gotta go.
All right, bro.
Alright, bye.